Hey there everyone, I'm Yak and Matt, and today's video is going to focus on deconstructing, dissecting, doing a deep dive in how I built this custom trolling motor steering handle that also contains the potentiometer that provides the forward, neutral and reverse functions for the trolling motor fitted to your kayak. When I embarked on my trolling motor fitment to my kayak, I knew that I needed to have something really different. Everyone had done the foot pedal steering, everyone had done the box mounted PWMs with the potentiometer and the forward neutral reverse switch. I thought I'd do something completely different. It's a custom side stick steering handle that steers the trolling motor, but also houses the potentiometer to control forward, neutral and reverse. As far as I was aware, nobody else had done anything like it, so let's check it out now. So my little blue kayak behind me was originally a paddle kayak only. It didn't come with a rudder. I didn't have the advantage of having foot pedals to control an existing rudder system. When I was brainstorming ideas, I'd seen a lot of guys have the little potentiometer and a forward, neutral and reverse switch mounted on their enclosure, a bit like what FPV Power and a couple other manufacturers make. And look, that's a nice simple system because you don't need to run additional cables. But I thought of something a little bit outside the norm. So when I was going through a heap of videos from Bassman Strikes and Axmaniac, look, those guys make some really cool videos. PWMs and the ESC systems. I did get the parts list originally from Bassman Strikes, a guy called Tony. And he did specify this particular potentiometer, which is supplied by Mouser. But unfortunately, when I've gone to look for this potentiometer on the Mouser webpage, they don't seem to stock it anymore. So look, there is other potentiometers out there with the center detent, and that's probably the most important feature that you're looking for if you're going to design an all-in-one steering handle and having your forward, neutral and reverse controls basically on the one hand control. So this potentiometer, I think it's a 10k ohm. It's a linear pot with the center detent. So it shouldn't be too hard to find something a little bit alternative to steer this thing, right? So I did see a couple of guys start to build a separate little steering handle and using, I guess, like a round pulley style system to control the lines down to the stern of the kayak. But I needed it to be something that I could make myself. So high density polyethylene is a material that you can buy from most plastic suppliers, and it's actually quite easy to work with. It does create a lot of mess, and if you get it a little bit too hot, it starts to melt and you have all sorts of problems. So you just got to, obviously, when you're machining it or cutting it or drilling it, is that you try and sort of not use an angle grinder unless you absolutely have to do your final finishing and those sort of things, such as like using a flapper disc or something. Anyway, so the design of this handle incorporates the potentiometer up here at the I guess the end of the handle. I've got a couple of build overview videos that I've done previously. I went with the transfer mounted trolling motor, and when you're doing up your wiring and those sort of things, you know, like I've got the Hobbywing ESC system and it's in a enclosure system like this with your power in and your power out. You might notice the hot RC little receiver in there. The challenging part of the build was working out where I was going to mount a suitable steering handle, and also to work out the steering system. So I've posted a couple of other videos showing how the steering handle works, but I figured I would do a bit of a deconstruction of this handle It is redundant now. It was probably just I suppose a bit of a trial to have a bit of fun and see if a trolling motor would work on the kayak. So straight away, there's a couple of pretty cool features that we'll dive into with this particular handle. The handle itself is constructed out of high density polyethylene, and I've used stainless steel screws to attach it all together. Now, one of the unique little features of this steering handle is I wanted the handle to be ergonomically sort of fit for my hand. So when I was sitting in my little blue kayak, I could easily rest my hand on the hand grip. The design, I wanted it to be able to use my dominant hand is the right, so I steer with the right, but I wanted the potentiometer to be able to be adjusted with my thumb. So you can see there the little center detent, the little white mark. So the handle design with the potentiometer up the top there allowed me to use my thumb to turn the pot forward, neutral and reverse. Especially important to find your neutral position. Otherwise, if you're cruising along and you want to kill power, if you can't find the center or the off function, you've got to hit the kill switch. But it also enabled me to steer. So we'll get into the steering function in a moment. But with the potentiometer, I had to actually flush mount it. You can see there I've got two halves to this handle. With the pot, I used a little stainless steel backing plate that's screwed into one half of the handle, and I'm just going to show you the ugly side because this was really the prototype. Unfortunately, I did get a little bit heavy with the Dremel drill. I think I actually used a router to cut this down, but it was got a little bit too much heat in the back there, so I actually had to drill out a bit of a recess for the pot to fit in. It looks ugly as sin, but it worked, and it was actually remarkably watertight besides looking a little bit messy. Anyway, as I said, it was only the prototype, so this will give you a pretty good idea of what you can do with your own handle. Okay, so yeah, it is a bit rough, but look, it worked as a prototype. So if anyone comes up with a really, really neat way of doing this, I would love you to tag me in any of your videos or your posts on Facebook. So one of the features I needed to have with the end of the handle is the pot needed to be, I guess, recessed as sort of in a narrow profile as possible. I didn't really want the pot to be much wider than the actual thickness of the handle, but I've you can see I've sculpted out a section of the high density polyethylene so that way there was minimal gap. There was minimal chance for anything to get snagged down in there between the actual pot and the material itself, but without sort of inhibiting the smooth movement of the pot. Now, the pot itself is just basically kind of level with the top of that handle. So you can see, there's, if we put a bit of a straight edge across, there's barely any gap between the pot and the ruler there. So it's I didn't want it too proud above the material, for the reason being that it could get easily knocked or bumped with this at that height and that sort of recess. It's actually a deliberate movement that you have to place your thumb on the pot in order to increase or decrease your speed. So I'm not going to go into any depth about how the trolling motor was mounted. I've got the trolling motor there, and I'll show you sort of some of the newest mods I've done to it. But getting the steering handle was probably the single most trickiest part of the entire build. So I couldn't find a pulley that would suit the needs. So I looked at different pulleys online, from gym pulleys through to sort of industrial pulleys. There wasn't too many in a piece of plastic that I could easily modify. Whereas with the high density polyethylene, I was able to construct it to exactly the right diameter that I needed for my project. Okay, so I settled on an overall diameter of 100 mils, across my steering pulley at the front. The reason why I went that is I did some sums on a calculator online, which was a pulley calculator. And if you Google pulley calculators, I'll see if I can find the original link that I can put in the description and also post up in the corner. With the pulley design that I landed on, I was able to turn my handle. Oh, look, that would probably be, you know, what's that? About a 25 to 30 degree angle, left or right. And my motor, because of the pulley ratio, having the larger pulley on the front and the smaller pulley on the back, a bit like your old fixie or your BMX bike you had as a kid, got the big chainring on the front, the little chainring on the back, and that meant you were able to go at a much faster speed. So this pulley would turn quite slowly, and then the smaller pulley at the back would rotate quicker. So a turn of around this angle would equal around a 90-degree turn of the motor at the stern. Okay, I just want to pause the action there for a moment and ask you one thing. If you're loving what you're seeing so far, or you've seen other videos on my channel about kayak fishing, the kayak modifications, I'd love it if you could subscribe to my channel. I love the interaction, and I love to see my viewers coming back and watching my videos over and over again. So if you like what you see, click the button now, and let's get back to the action. Now, I'm not going to get into too much depth about how to mount your handle on the side of your kayak, because every kayak's going to be different. They're all going to have different shapes of the gunnel. Some are going to be like a Hobie that have got the H rail. Some have got the track mount that you mount all of your accessories into. With my kayak, I didn't actually have any track mount. All I had was the bare hull, so I had to make a bespoke pedestal, I call it, for the whole handle and pulley to sit atop. So what I've got here is I've got a stainless steel bolt, and I think it's like a 10mm metric bolt that would mount through the actual pedestal. On the underside of the pedestal, I also had a nylock nut, and I had a stainless steel washer, and then I had a nylon washer. On the underside here, I also had a nylon washer and a stainless steel washer. So this is just a bit of a rough sketch. You can see what I used was the same thickness high density polyethylene. So it was a 15mm sheet of high density polyethylene that I'd got as an offcut. The two side brackets here and here, and I'm going to show you where it mounted originally on my kayak. They were shaped to suit the side of the kayak. So this is a cheap little Chinese kayak that I've got behind me, and it had the curved sides. Inside here, I used two stainless steel brackets, and then I simply had some nutserts. I think they're called nutserts, or through hole fittings. Anyway, they're those rubber well nuts. They're called well nuts. I had the well nuts drilled into the hull of the kayak, and then on the inside of the kayak I also had a couple of brackets that just connected and clamped onto the top. So essentially what would happen then is you'd have your, let's see if I can hold that up there, put my elbow on it. So you had your steering pulley there, and then I had my handle like so. I had that little gap there, so you can see the bit of a shape. And I know it's a bit of a rough sketch, but you kind of get my drift. Now there's a reason why I'm not a graphic designer, and this is exactly the reason why I'm not. But you get a bit of an idea. So let's go on over and have a look at the actual side of the kayak where this pedestal mounted, so you'll understand a bit better why those two brackets are curved. Okay, so originally, and if you've watched my other videos on the build and the construction of this particular setup, this is where the actual bracket clamped on. So the handle mounted on top of the pedestal, and if you can imagine the pedestal there, and I use the handle like so to steer, and hopefully I can find a little video to link on the screen and you can see how that will turn. I ran 2 lines that wrapped around the pulley and they hooked onto those little screws there you can see. So those little cutouts just allowed the line to slip into the actual pulley groove itself, and I'll explain how I made that pulley in a moment. But the lines then travel down the hull through a little eyelet here and then through another little pad eye here. This is just in Australia they're called P&P, little deck fittings, and then yeah, the lines went through there, and I had a little eye bolt, and then the lines went up to the motor. So I'm not going to teach you how to drill and machine and cut high density polyethylene. All I did to get this quite a nice round shape was I used a 100mm hole saw, just a metal hole saw, and I had to use a drill on a pretty low speed to be able to cut through this thickness. So I think it is, it's 15mm high density polyethylene, or HDPE. So it did take a while to be able to cut through that thickness. After that, all I used, I already had a center hole that I'd obviously that your bore or your center of your hole saw goes through, like your pilot hole. I put a bolt through it and pretty much clamped it in position, and then I used a angle grinder with a flapper disc with a fairly fine abrasive to machine down the surface. So once I'd got the overall diameter to where I wanted it to be, I then just used a grinding disc to, once I actually clamped this pulley into position in a vise, obviously through the bolt, so the actual disc could turn, and I just machined a groove. Now there's probably much easier ways to do that than using an angle grinder. If you've got access to someone with a lathe, surely they can make up a pulley. Look, my goal was to make it all myself with using very little off-the-shelf parts. So I think I've pretty much achieved that. Anyway, so as I said earlier, the rope would go around the pulley. So one line would come up this side, it'd travel around, and then it'd go up through this groove, and I just had a little loop tied on the end, went around the screw, and I tied it down, and the same on the opposite side. So it's, if you've got a native Titan or another kayak that's got a steering disc or a steering drum, you'll sort of know what I mean. Let's get into the nuts and bolts of the wiring. So I didn't want to have any loose wiring externally to the handle, and you've probably been wondering all along, what's this blue cable doing hanging out the bottom of the handle and the steering disc, and how the bloody hell did that get in there, you'd probably ask. Well, so all I've used is a Cat5 cable, so it's a pretty common cable you can get from your hobby store, or in Australia we call it Jaycar. You might have Home Depot or Walmart or any of those automotive places or computer stores. You can pretty much buy it anywhere. You can get it on Amazon, eBay, you name it, you can buy it. The potentiometer, as you'll see in a moment, has got 3 terminals. It's got a signal, ground, and a power terminal. So you need to run 3 wires. So the advantages with having the cable actually go up and inside the handle is when I was steering the handle, I could operate the pot, I could steer the handle at any angle I wanted to, and I didn't actually have to worry about the cable. So one of the neat little tricks I did with the actual pedestal, I'll just draw a quick picture. So the pedestal itself was around 110 millimeters square. Now, I didn't really sort of engineer it especially to that size. It just seemed to be a nice fit for the size versus the actual diameter of the pulley. But so it was just a square section. If you remember back to my drawing, so that square I just showed you is the top plate. It's the top of the pedestal. So through the center of the pedestal, all I did was drill a corresponding 10mm hole to take this stainless steel bolt, so that you could see when I had it mounted, the handle would sit nicely on top of the pedestal, and it just provided a nice little structure to bolt it to. So I had a hell of a good time working out how I was going to turn the handle with this Cat5 cable, essentially coming out the bottom of the pulley. Now, there's no way that Cat5 cable had the ability to turn on itself. You probably could, get a longer bolt and maybe use a spacer or something in there to help to space out the pulley off the top of the pedestal. But I come up with a pretty cool idea, and all I did was I calculated where the actual Cat5 cable came out the bottom of the pulley, so you can see relative to the bolt, and I just machined out almost like a crescent shaped hole. So I'll just show you that. So you can see there that crescent shaped hole that I machined out of the actual top plate allowed the handle to essentially, if we look at it like this, it sat on top of the top plate. So it sat on top of the top plate. The bolt would go through the center hole, as we can see there, and then that cable, relative to the position of the bolt, went through that little half moon or crescent shaped machined out section in the top plate. So that way I had the ability to turn the handle through that sort of 90-degree included angle, and the cable never fouled up. So once with this particular pedestal arrangement, that particular cable, all I did was it came out down the bottom, and then I had that little cable go off into the hole. So I'll show you that there. So yeah, that little blue cable had it come out from underneath the pedestal down into the hole, and then I had it actually go into this fitting here, which is where my wireless receiver is. So I'm not going to go into how I fitted the potentiometer to the servo tester. So there's lots of really good demonstration builds on how that's done by Axe Maniac and Bassman Strikes. Alright, it's time to deconstruct this thing so you can get a bit of an idea of how this cable runs up through the handle, up through the shaft of the handle, and out to the potentiometer. Before I go too further, look, this shape of this handle, the dimensions and the size and the thickness and everything like that was suited to what was comfortable for me. So it's probably just something you need to use a bit of MDF or a bit of custom wood or a bit of plywood to build a bit of a mock-up, so you can get a feel for what's comfortable before you make your own. So that's really important, because look, I don't really want to give too many dimensions on this. I could probably draw a bit of a sketch and give you a rough size, but look, if you know the length of a 30 centimeter ruler or 12 inches, look, the handle itself is, what's that, probably 15-16 centimeters long, and overall height is probably 120 millimeters. So what's that in inches? 4 inches or 5 inches or 6 inches. So yeah, it's probably 7 or 8 inches long and about 4 or 5 inches high. Alright, so I just used a combination of stainless steel fasteners. These screws, they're a 10 gauge screw, and I really had to think long and hard about how the handle was going to go together using two different halves, and how the cable was going to run through from the pedestal. So we'll put that in the right orientation. The cable comes up into the handle, and then how it was going to go up the inside of the handle without too much difficulty. So let's pull this apart. So it's a good idea, when you're using any stainless steel fasteners, that you're going to actually screw into the HDPE, is you drill a bit of a pilot hole first. Otherwise, you're just going to have all sorts of nightmares. You're going to end up causing the plastic to expand or crack. Look, it is pretty workable sort of stuff, right? Like you can do lots of things with high density polyethylene, and it's the timber of the plastic polymer world. So, but look, pilot holes definitely make things a lot more simpler. The reason why I used fasteners in this sort of gauge, so they're like I said, they're a 10 or a 12 gauge self-tapping screw, and they're probably like a 1 1/4 inch long screws. That way they've got a nice little bite down into the actual plastic itself. Provides a bit of structural rigidity and strength to the handle, because I really didn't know what kind of forces would be on the handle when I'd be turning it. If you think about the amount of torque that the Ming Kotas and the water snakes put out of the prop torque, I didn't quite know what I was up against. All right, so we've got the fasteners out now. Now, just watching this particular disc here, so we'll just separate that, and you can see how that Cat5 cable is run through its separate hole, and just ignore the fact that the holes are a bit offset. As I said, it was a prototype. Ended up working really well, but I'm sure there's some really good engineers out there in YouTube world who will probably do a much neater and better job than me, but it gives you the idea anyway. All right, so we'll get rid of that stainless steel bolt. All right, so there's the underside of the actual handle itself. So when I put this particular handle together and I shaped it, I originally had 2 sheets of high density polyethylene, and I screwed them together. So you can see there I've got a 12 gauge screw there, and then down the bottom here I've got another 12 gauge screw. So look, that was to hold the 2 pieces together, while I roughed out the shape just with a Nico or a Sharpie pen to the shape I wanted, using a template that I had out of cardboard, and then just used a jigsaw to shape the rest. So look, you wouldn't believe that's 2 pieces of plastic screwed together. It does look a bit rough, but if you're handy with the heat gun, or really want to spend a lot of time finishing the plastic, I'm sure that you'll have this looking just like a single piece. Okay, so we'll take this apart now, shall we? All right, there's one. Okay, now prepare for the magic. See, there you go, nice and easy. So all I did was I machined a little groove for that cable to sit in. Now I've only machined it on one side, so I used a bit of grease in there, a bit of silicone. I know it's probably, you're going to say, yeah, it looks really rough as guts, Matt. You can see the potentiometer in there. It's this little stainless steel plate. Look, you get the idea, right? It worked. It never had any problems. As far as I can see there, you can see that there's no real corrosion on those little terminals, because I did fill it full of some dielectric grease. But anyway, that Cat5 cable runs down the inside of that plastic really nicely. All I used was a grinding disc to carve that groove out. Now, what I had to make sure of when passing that particular Cat5 cable through the, I guess you could say, that's the handle. You had the the pulley and you've got the pedestal, and you could say this is the legs of the handle. So the actual cable, you just had to make sure when I had it come out that it didn't interfere with any of the screw attachment points for when it would bolt on top of the pulley. So I made sure that when I drilled the and when I machined that groove for the Cat5 cable to run down, is it didn't interfere with the existing fastener holes. So when I assemble it all together, you know, I wouldn't put a screw through a critical part of the cable. So that's a bit of a deconstruction of my custom joystick handle. So, you know, I had the 10K pot with the center detent. You know, I had to machine out a little groove or a little recess for the back of the pot to sit inside that plastic. You know, there was obviously a lot of soldering. I'm not going to go through how I did that because, again, you know, there's thousands of videos on how to solder a piece of wire to a terminal. But I think this particular handle design was really, really unique, right? Like, I looked on DIY kayak rigging, I looked on the motorized kayak fishing pages. Look, I haunted all of the kayak mod pages, the different forums, the different groups, and I just didn't find anything that resembled this particular handle design. So I know I did share some photos on a few groups. It did attract a lot of attention. I've got a little video that I filmed. It's like a minute and a half or something like that, and it's had something like 5,000 views. Not a lot of questions about it, but I'm sure there's probably people who worked out how I did it. But anyway, what I encourage you to do now is reach out to me, leave a comment down below about anything that you've seen. If you've got any questions, you know, I'm happy to chat offline. So you can find me on my Facebook page called Yak and Matt. So it's YAK apostrophe N, and then my name is MATT, Matt. You know, contact me on Messenger if you like. I am in Australia, so I am on a different time zone. So if you're in North America or in Europe, if I don't answer you straight away, you understand why. So if you're after any technical videos about how to put together the Hobbywing ESC, the 880 ESC, and the wireless receivers, or how to modify the little servo tester to provide your PWM signal to your ESC, have a look at Axemaniac, like I said, or Bassman Strikes, or just type into YouTube, search for PWM for trolling motor, or Hobbywing ESC trolling motor, or how to wire a servo tester to a trolling motor and those kind of things. So look, you know, hopefully you've stumbled across this video today through your search on ideas just like I did. I hope this has really given you some great insights into what you can actually achieve by using some simple materials with some hand tools you've got in the garage or the shed at home. But like I said earlier, make the design how you like it. You know, this size here is not going to be fit for everyone. Yeah, if you've got a bigger hand, it might be a little bit more difficult. Depending on where you're sitting, you might want your handle a bit higher. But all in all, you know, have a lot of fun like I did. I didn't believe that I could actually achieve what I've achieved with this system. You know, I needed to upgrade my kayak to something a bit bigger because, look, I'm not the biggest bloke and I'm not the smallest bloke, but I just needed a larger kayak so I could stand up, have a bit of a stretch of the back. If you've seen some other videos of mine, and I'll chuck those in the links as well, with my Native Titan 10.5, I've also fitted a Minn Kota trolling motor that came off that little blue kayak we looked at before. And this was the handle that controlled the same trolling motor. So that's the trolling motor there. So if you remember my other videos, you know, look, I've butchered the bracket there and done some other mods. I'm actually talking to a fellow on Thingiverse at the moment to talk about a wireless steering setup with a servo. and how it would adapt to the Minn Kota system. So watch this space. I'm Yak and Matt. I really hope that you got something out of this video today, and that you've watched it all the way through to the end. And if you've really loved what you've seen, or if you've seen my other video clips on YouTube, please subscribe to the channel. I love to see every time my channel grows with its following. I love to see I guess where all the viewers come from. I've got viewers in North America, right across Australia. I've got viewers in Russia. I've got viewers in Japan, South America, Indonesia. Look, it really stuns me where my viewers actually watch my videos from. So thank you very much for taking the time out of your day to get a bit of an education in how I achieved my little steering handle. We'll look forward to catching you on the next one, and bye for now.